All right, ladies and gentlemen, section 5, 6, properties of special parallelograms. So everything we look at today for a shape falls under the umbrella of a parallelogram, but then it's a more specific shape that we already know. So the first one we're going to look at is a rhombus. A rhombus is a parallelogram with two pairs of congruent parallel lines. And so all four sides are congruent, and then opposite sides are parallel to each other. We have some special properties here for rhombus. The diagonals of a rhombus are perpendicular. So that means that these angles all in the middle are going to be 90 degrees. All of these are 90 degrees. The diagonals of a rhombus bisect each other. So you'll see it cuts it into two equal parts here and two equal parts here. Now the diagonals are not congruent to each other, but they bisect each other into two congruent parts. And the diagonals of a rhombus bisect the angles. So in the angles in a rhombus follow the same properties of a parallelogram. Your opposite angles are congruent to each other. But now in a rhombus, they are going to be bisected. So this part here is going to be congruent to this part here, and so on. If this whole angle here is congruent to the whole angle down here, when they're bisected, all four of these are going to be congruent to each other. So if one of them is 25, all four of them are 25. If one of them is 76, all four of them are 76. The same thing goes for the opposite angles. These angles are already congruent to each other, so when they get split, it's now breaking it into four more congruent angles. All right, another special type of parallelogram is a rectangle. A rectangle is a parallelogram that has four congruent angles. So those corner angles are now 90 degrees. A rectangle still follows all the same properties of a parallelogram, but has these a couple additional properties. The diagonals of a rectangle are congruent. So my diagonals, like AC, is congruent to BD. The diagonals are congruent. And now the diagonals of a rectangle bisect each other. So that means it's going to split this into two equal parts and this into two equal parts. But remember, if the diagonals are congruent to each other and it breaks it into congruent parts, it means all four of these sides are going to be congruent to each other. So we actually, our diagonals are going to bisect my my rectangle into four isosceles triangles. So that's pretty cool. It does not follow the rhombus property. So just keep in mind, those properties for a rhombus are for a rhombus and not for a rectangle. Then that brings us to a square. A square is a unique parallelogram because it's an equal angular rhombus, so it follows all the rhombus properties, but has all the corner angles to be congruent. And then a square is also an equilateral rectangle, which means that all the sides are congruent, and so it follows all the rectangle properties. So squares are pretty cool. They cover all the rectangle properties, all the rhombus properties, and all the parallelogram properties too. In a square, the diagonals of a square are congruent. So AC is congruent to BD. Um, and the squares of a diagonal are perpendicular. So all of my inner corners here, or inner angles, are going to be 90 degrees. And the diagonals of a square bisect each other. And because remember, it's like a rectangle, all the diagonals are congruent. That makes these four into congruent sides. Now, one thing that's not typed up here but is a rhombus property is that the diagonals bisect the angles. Okay, so if all my angles are 90, that means that these are now 45. All of them are 45. All of these. Okay, so just some really cool things about these triangles that are formed are isosceles. These triangles were all the same here. They all have 90 degrees and the 45 degrees. All the hypotenuses are congruent to each other. So just a whole bunch of cool stuff. All right, so here's some practice for you. And we'll see you in class.